Hi guys, I'm working on getting Home Assistant up and running in my house. In that process I decided to make this SCD43 CO2 sensor testboard in order to make some of my IoT devices equipped with CO2, temperature and humidity sensors. This is just the initial prototype, the final ones might be even smaller and include other cool features. In this video we'll go through the whole design process, from making and designing the schematic to route and ordering the PCB at PCBWay. The main features for this board are: we will use an SCD43 Sensirion CO2 sensor, we will use an SHT31 Sensirion high precision temperature and humidity sensor, we will have an LED on the 3.3 volt rail, we will use two quick connectors for I2C and power, and we will have one in each end of the PCB. And for the mechanical side of things we will have 4 3.2mm mounting holes. The size will be 40 x 29mm and it will be a 2-layer board design. Now stop waffling and let's get started and fire up KiCad. Just before we start the project, I would like to thank PCBWay for making this video possible. Remember that there are a large section on PCBWay.com where you can find a lot of projects and inspiration from other makers. If you find a particular project interesting, then you can often directly order the PCB at PCBWay. You find my affiliate link in the video description of this video. Please use it and thereby support the channel. So remember to visit PCBWay.com. So let's dig into it. So here we are in KiCad. I already made this new project and named it SCD43 testboard. And let's get started with the schematic design. As always, we go to page settings. And I need to grab it here. And we will put in the date and a revision number. And the title, that will be SCD43 testboard. And made by Morten. And we will have it on a A4 paper. I think that's fine for this small design. And here we have the details. So let's place the most important part, that's the SCD43. Place symbol. And we already have it open here. I would like to have SDA and SCL on the other side here. So we can just try and edit that. Let's place it here. And then we can just say edit parts. That's fine. And we can just move this text a bit here to the other side. Like that. Then we grab the pin here. And we will try to mirror it horizontally. Or horizontally, move it. I think this is fine. Just like that. Okay, and then we can close this, save, file, close. And here we have the part. We can just move the text a bit here. And the next part is an SHT31. Like that. And then we need two quick connectors, and that will be, just remove this and then try to find some connectors. And it will be connector generic and 1x4. And we will need to rotate that one as well. Like so. And we can just try and figure out the pinout for this quick connector. We can draw some wires first. Like that. And let's see, I found a pinout here on Hackaday. So SDA is pin 3 and SCL is pin 4. L for label. SDA is on pin 3. L for label, SCL, and we could call it AMTECH SCL. We will call this one AMTECH SDA. And let's see plus and minus. We have ground on pin 1. We can just take and move this out a bit. Wire. And place power. I think we have a ground symbol down here. That one. M for move, like that. And on pin 2 we have 3.3 volts, and we would like to have a small 10 micro bypass capacitor there. G, that, wire. Place power P, and we have plus 3.3 volts, like that. And we need a small capacitor. C small, I think it is, yes. And we can grab the ground symbol, duplicate it. Like that, and that should be 10 micro. 10 volts. like that. And the type number for this part, that's SMB, I think. Let's check it out. You can see if we can find the part number here. This is this part, SM04B. And we can just insert it here, like so. And I would like a second one in the other side of the board, so let's just place it. Duplicate this one. And then go down a bit. And I don't need the bypass cap on this side. Like that. And save. So here we have the two sensors, and the reason why I chose to have a second humidity sensor is that the humidity sensor inside the SCD43 is not very accurate, and it's much more accurate here in the SHT31. And we can just have a look on the datasheets here. I found the datasheet for the SCD43, and we can just look at the humidity sensing performance. So we have the accuracy here, so plus minus 6%, and in a larger temperature range it's up to plus minus 9%. And if we look at the SHT31, then we see, let's check it up. Where do we have the data? So here we have the SHT accuracy tolerance for the humidity sensor, and that's plus minus 2%. So that's much more accurate. So that's the reason why I have decided to have the two sensors on the board. But let's try and connect those two sensors to an I2C bus. Let's move it down a bit here. And we can grab the two labels here. Something like that. And we can draw the lines. G, like that. And here we need to rotate the part. Like so. SDA. And then we have SCL. Like that. And on the I2C lines we need the pull-up resistors. So we'll find a resistor. And we need one on both lines. And that would be for K7. I think I need to change the grid a bit here for this. And we can just see what do we have here for text. 10 mils. It's quite strange that it moves 50. Let's take preferences again. Yeah, that's strange. 4K7. And we can just look at the preferences again and go back to 50. For the SDA line, duplicate. Wire. And let's grab the 3.3 volt net. Duplicate it. Like that. Then we have the I2C communication in line. And let's attach some power to the CO2 sensor. And we also need a bypass cap for that one, or two bypass caps. So here we have one of them. We will have a 10 microfarad, and then we will have a 100 nano as well. Like that. And we need a bypass cap for the humidity sensor. Just grab this block, attach it here, remove that line, like that. Then we need to attach this to 3.3 volts, and all the ground lines here needs to be attached to ground. Like that. Just rename this. Like that. And then we have the humidity sensor, and we also need ground pin to be connected. Like that. And then the alert pin, we will not use that one. We can just place a not used or not connect flag on that pin. And then we have 3 more lines. So the R pin is just going to be connected to ground. We can remove this. And the reset pin, we will just have a pull-up resist on that one. So we can grab this one, duplicate that. like a 10K resistor. Like so. So we have the address pin here. We can either tie that to 3.3 volt or ground, and then select the address that way. And I'll just pull it down to ground. Take this 10K ohm resistor and then a ground symbol. Move it down here. G. And then we need, I would like to have, we can just put a solar blob here and then connect it to 3.3 volts. So if I copy this one, and let's see if we can find a solder jumper. And it should be this one that are open. So if we just put a small solar blob here, then we will have the address pin high. So that's basically the sensors. I would like to just put a few labels here or some text here on the connectors. Let's try and move this up here. Like that. J1 like that. J2. And the text up here. Something like that. So we can just place some text in front of the pins here. Place text. Draw text. So the first pin is ground. Then we have VCC. Then we have SDA. And then we have a seal. Like that. We can duplicate this. Like that. And save. And finally, I would like to have a small power LED that shows that we have 3.3 volts on the board. Yeah, I could have just, let's delete that. Just take this block. Like that. And that should be like 1K. And let's find an LED. That. And that should be like a green LED. And we need a ground symbol. Like so. So I actually think the PCB or the schematic here are complete. Maybe we should also just place the mounting holes. And we need 4 of those. Alright. I think the schematic is done. We could just make a annotation of it. So we go to Tools and Annotate Schematic. And it goes in this zigzag mode. It's fine. Annotate. Close. It looks fine. I was just wondering what went on here with the text. It's a bit strange that they are not aligned. It has something to do where this cross is. Can we maybe align it this way? No, it's aligned this way. File, save. And what else should we do? We should assign footprints to the board. And the way that I normally do it is just to go to this thing called Edit Symbol Fields. And here we actually have all the data for the board. And you see here we can fill in the footprints here. So the footprints for the capacitors, I would like this to be 0402. And I will just load all the footprints that I have. Like that. And let's find a resistor. And that's SHT. And we should have one in SMD. Here we have it, and R0402, and we could take the hand solar ones, they have a larger pad, and we have the 10 micro capacitors. That could be an 0603. Then we have a green LED. And let's find a 0603 LED. O603. Could also find a hand soldered one. Mounting holes, that was 3.2 millimeter ones. Let's find mounting hole. And that should be 3.2 millimeter. Let's see. Take this one. Then we have the quick connector. Let's see if we can find that one. Something went wrong there. Let's check out if our symbols were saved. And they were not. I don't know what happened to KiCad. That's bad. Then we have to do it all over. no worries. So this is a resistor. SMD 0603 0402 and sorry, this was the capacitor. Capacitor SMD and C0402 hand solder, and we need some 0603 ones for the 10 micro, and then we have the LED. And that was an 0603 hand solder. And the mounting holes, that was mounting, and 3.2 millimeter. Then we have the connectors here. SM04. I don't know what's going on here with my program when it tries to search for that part. That's really strange. I think there's like a glitch here in the schematic editor. Close. Tools. Edit symbol fields. Let's try and do this as the first one then. Datasheet to footprint here. This one. Then let's just try to see connector. I think that's a JST connector. SM04. This is not the one. SH. There we have it. Like that. Let's try again and find the right ones. And we will have the capacitor. We can just close down all this connector. Like that. Then we have capacitor. SMD. And we have the 0402 hand solder. And we have the 0603 hand solder. Then we have the LED. We know it now. LED SMD. And that one. Mounting hole. Mounting. Okay, let's say apply, save, and continue. Then we have this soldering jumper. Solder jumpers. Let's see what we have. Open rounded pads. I think that's the one we need. Okay. The rest is just 0402 resistors. Let's find resistors in SMD. 0402 hand solder. And then we can just copy and insert like that. Apply and save. So now we have all the footprints defined. We can say apply, yes, and OK. Yeah, I don't know what happened in the when we had to define the footprint. Something happened and it reset the schematic editor. But now we have all the details ready and we can start laying out the PCB. But I think that we should take a small break and see you soon. So welcome back after the break. Let's get started with the PCB design and start the PCB editor here. And we have a blank sheet and we can just import all the parts. So we say tools, update PCB from schematic, and then it actually loads all the parts that we have from the schematic design. And here we have all the parts imported. So I think that the first thing I would like to do is to place the board outline, and that's done here in the edge cuts layer. And when I click on this, you can see the small arrow here, and that points that this is now the active layer. And let's place a rectangle, and the grid, we would like that to be 1 millimeter, and we say it was 40 times 29 millimeters. Something like that. And we can make some nice rounded corners. Right click here, and then we could see shape modification and fillet lines. And we would like the radius to be 4 millimeters. And now we can take the mounting holes. And you see this actually fits quite well. And it's very nice to do this on a 1 millimeter grid. And move like that. And I would like to remove the designator from the mounting holes. They are not being, it's not a part, it's just a part of the PCB. And then we could take and fill in the connectors. We would like to have one here in each end. Like that. And one in the other end. Like that. And I would like to have some dimension on, and we could say place, draw dimensions, and I would like to do that in user one layer. Place, draw dimension. And this is 25, 40. That 40 millimeters. Place, dimension. And the center of this one should be 14.5. Let's say to like that. Place, draw dimensions. I need to get this one because it snaps to the connector here. Place, draw dimensions. Like that. 14.5, so that's the center line. We could also make a grid point down here. And we should be able to do that. Place, grid origin. There. Then see down here that we have 0.0 here. Like that. So let's see if we can have the center moved here from this part. I think this is quite nice. And we can just have a small line here. Draw lines. And we are still in the user layer. And like that. And there we have the edge, so that's perfect. So now everything is aligned. We have the board design, and we can just start and drag in the parts. So the most important part is the CO2 sensor. Then we have the humidity and temperature sensor. Just around here. Then we have the LED. And the corresponding 1K resistor. 10K. And we can move this up here. Then we have the solder jumper. Can just put it down below here. And Then we have 2 resistors. Something around here. And then we have the pull-up resistors for the I2C bus. And we have the second one. Something like that. And this is the pull down resistor for the solder jumper. There. And then we have some bypass capacitors. Let's check up on the schematic. That was C3. Close to the connector here. That. And then we have for the CO2 sensor. Could maybe have it here. That. And one of the bypass capacitors. And this is for the humidity sensor. That. And the final bypass capacitor. And that's for the CO2 sensor. Like that. And we have a lot of text here. We can just try and hide that one. Is that user drawing? No. So this is so this is a fabrication layer. We can just hide that for now. We don't need all that information. It just makes it a bit more complicated to look at. So we just do it like this. And we can just take a peek on the 3D layout. So here we have the board. See, we are missing a few of the SMD parts, but we can find the models a bit later in order to make a complete design. But I'm happy with the way it looks right now. I think it's time to just route some of the board. And let's save it for now. So we can start with just attaching the bypass capacitors to the 3.3 volt net. And I would like another grid for that. I think I'll go for a 0.0525 millimeter grid. that. And we have a bypass capacitor here. So this is just a 2-layer board. So we just to be a bit careful about the power. Like so. And we can just put that in there. And we can route this we'll go up here on this side. Can maybe move it up a bit. Like that. And we have 3.3 volts here on the pull-up resistors. And we need to go in on the bypass cap first, and then to the 3.3 volts. That and let's go down here on this side. All right, we can connect 3.3 volts here. That. And connect the LED here. And we need to rotate this, of course. Like that. And this will go to the reset pin. Like that. Just need to smooth this corner out a bit. Like that. And I think it's time to route the SDA and SCL lines. You can take the SCL line here first. That should be the simplest thing. And let's place a via here and go to the bottom layer. Draw the SCL line down here. Place it here. But then we can continue up here. That, and And then we can just take this label, move it up here. Something like that. And we can take the label for this connector and place it up here. Like that. Next is the SDA line. We'll just jump over all this with a via. Like that. And let's go down here. And we should be, it's fine on this side. Be here on the inside. Like that. And we have a lot of ground here. Ground 3.3 volts. See how we can get 3.3 volts around here. Let's go this way. And let's take it around here. Connect it up here. Yeah, maybe we should just use a via. Yeah, like that. And then we can just place a via here. Place via. That's player. Like that. Three point 3 volts all the way through. 3.3 volts connected here, and we need to connect 3.3 volts down here. we can just go on the other side here. Bottom layer. That's so I think we have most of the signals routed now, and we just need to connect some of all the ground pins. We need to take this one out. There's this one going to the solar jumper, to the pull-up resistor down there. Just take it out here. Place a via. Like that. And we will just save this. So we can just place some vias close to the ground pins here. Then we can make a copper pour afterwards, and then connect hopefully the most of them. Duplicates. This looks fine. This one is okay. Ground point up here. Ground here. Like that. All right. File, save. And now the reason why I have some spare room left is because I want to write some text here. I want to have some text here. So let's try and see if we can put some copper pour on. But maybe first we should try and make the wires here for the 3.3 volt line a bit thicker. So it's 0.2 millimeters. I would like that to be 0.4 millimeters, and then I just need to take care of this one afterwards. So the way we can do this is to go to File and Board Setup. And then we have some constraints, design rules, or net classes, sorry. and we could just say we could add a new net class, call it power, and we should set the clearance to be also 0.2 millimeters, track width to 0.5 millimeters, and then we should add a net here. Default power, and that should be plus 3.3 volts. Okay. And let's see if we can update that net. Plus 3.3 volts. I just need to see if I made something wrong there. Port setup. Track width. Okay. Properties. I think that should be 0.5 millimeters. Plus. Really strange why it doesn't update that net to be thicker. Let's try and then just manually do it. You can press U and it selects all the net to the next connection, and then hold control button down. And properties, and that should be 0.5 millimeters. And we can just say U. And properties 0.5 millimeters. And then up here, this is fine. This is fine. Just need those to be a bit thicker. And 5 millimeters. Point 5 millimeters. All right. So we can try and make a copper pour here on the top and bottom layer. Place fill zones. Place fill zones. And we would like to have ground on both top and bottom. And that should be ground. And we want the clearance to be 0.2 millimeters. Sorry, 0.2 millimeters. And 0.2 millimeters and 0.3 millimeters for the spoke width. Okay. And then we just need to make a rectangle around this. Press B and then it will update the copper pour. This looks quite nice. And we can go to objects and we can take the zones here and make it more and more visible. And we can just say view, 3D viewer. And we should maybe have a bit more copper pour here. We can easily fix that. We can just drag this down a bit. Should just set the grids a bit smaller. And then we can take a via and fill it in here. And of course we need some more copper. So we need to do like this. Like that. So now we can see we have copper pour in the top layer. Perfect. Just move that away from the via. A bit that way. Perfect. So let's write a few details on it. I would like to show where we have the addresses. I would like that to be visible. So let's see. I think I'll just call this one S instead of jumper 1. If that's possible, let's go back and see the PCB design and then rename this one. Is it possible to rename that S1? Okay. And let's see what happens when we update the design then. So we have now the designator S1 here. So let's write some text. Could be draw texts. So we want some I2C address. And this should be on the Silkscreen. And that should of course be not mirrored. Like that. And 0.15. And we just need one line per sensor. So we have the SHT31 and that should be, can try and look in the datasheet. SHT31, and then we need to find the addresses. Typically this is in the beginning here of the protocol. So here we have it. So the default, when the address pin is low, it's address 44 hex, and if it's high, it's 45 hex. So when it's closed, it's high. Yep. So let's put that in. So we have 44 hex when S1 is open, and it's 45 hex if S1 is closed. And then we have for the SCD43, and we can just have a look on what address we have that on as default. So that's address 62. Like that. Okay, just move this down. Something like that. And SCD33 or 43. And we can just align this together. Align to the left, like this. Nice. And down here I just want to write some type numbers. I want this to be over here. And we have the part numbers. We have an SCD43-D-R2. And we can just highlight that we are on the Silkscreen layer, just like that. And we have the SHT31, this, and that's the F2.5 KS. And just a bit of commercial for the channel. Home. Like that. And let's try and align this. To the left. Don't like to have the VS inside here. And we can just not select the texts. Like that. And we can place the YouTube logo. I think I have one here. Then I need to move this resistor and this stuff up here a bit. I think that's possible. Sorry. Just need to make it not visible then, like that. And let's see if it's possible to move this stuff up a bit. Drag this down a bit like that. Like so. And we can take the designator . move like that. Save. And on the back side, I would also like to have a few comments. See, the text size of this is 1:1:15. Yeah. So let's place a KiCad logo. And let's go to symbols. That's fine. Place some text. That could be let's add some more. That, and we could make that a bit larger. You can see how this looks. Yeah. We need to flip this to the other side. Just press F. That's file, save, and we can just say view 3D viewer. Yeah, we can see. Need to drag this text down a bit. Got a bit too close to the logo. Like that. And we can just place a few more VS, just scatter them around. Oh, that was the wrong one. Like that. And update the copper pour, and then we can make a design rule check. And let's check if we have some issues, some tracks we haven't connected yet, or if something goes wrong. So we have something here. There's a unconnected net. So this is this pad there. And we can just route a track in there. And let's do it again. And then we have some other errors. We have the pads. They say here that they are too close to the edge. We can just maybe make another rule for that. And let's see, constraints. Copper to edge clearance, we can make that 0.2 millimeters. And we can make an update, and let's see if we still have the same. And then we have all errors are gone, and there are no more warnings. So the final thing I would do in order to make this look quite nice in the 3D viewer is to put on some of the remaining parts. So we have the quick connector, we have the two sensors, and let's find those. So the 3D model. And this is this one. And we need to rotate it like that. And offset Y. Put 3 millimeters. And set looks nice. And we do the same with this one. And Y was 1.3 and Z was minus 0.3. Then we have the SHT31. And we need to rotate that a bit. Okay. We have the SCD33 sensor. There we have it. Seems to be embedded a bit in the PCB. Zero point 9, 8, yeah, 0.8. And we see this marker, that's pin 1, that's fine. Then we say view, 3D viewer. And here we have all the parts, they are now on the board. It looks very cool. That's quite fast to make a small breakout board for the SCD33 and the small SHT31 sensors from Sensirion. And with a quick connector interface and a small power LED here. So the final thing we can do is to submit the design to PCBWay, and you see this icon up here. There's a plugin. I can just press this, then it will just process all the data and it will automatically upload all the design files to PCBWay, and you are ready to make the order. And down here you can specify if you have some special requirements for, you know, the colors or the plating on the board. So that was it for now. Enjoy KiCad and see you in the next one. Bye.